amid the quiet breath of the cosmos, when the stars pulse like ancient hearts. Peggy Whitson returned with a revelation that stirs the human soul. A planet with 99.7% chance of life. This is not merely a scientific discovery. It is a promise of companionship across the vastness of space, an invitation to see ourselves reflected in the light of another world. If you have ever wondered whether we are truly alone in this endless ocean above, leave a comment and share the reason why you believe, or do not believe, in life beyond Earth. And now, what exactly did Peggy Whitson find on planet K218b? In the quiet drift of the cosmos, where starlight folds like silk over the dark, a new whisper has begun to move through humanity's collective imagination. Peggy Whitson's discovery on the planet K218b has become more than a scientific announcement. It has become a soft tremor in the heart of our species, a reminder that the universe may be far more alive than we dared to believe. When she gazed into the spectral fingerprints of that distant world, suspended 120 light-years away in the constellation Leo, she saw a chemical glow that should not exist in a lifeless sky. A signal so delicate and yet so insistent that it felt like a breath coming from another shore. As Carl Sagan once said, "Somewhere something incredible is waiting to be known." And perhaps K218b is that something. What Peggy Whitson found was not a mountain or a river or a civilization etched in light, but a molecule, dimethyl sulfide, drifting through the planet's hydrogen-rich atmosphere with a quiet confidence that only life can produce. On Earth, this molecule is woven into the gentle labor of living things, created by marine phytoplankton swimming beneath our oceans and by delicate microbial ecosystems that breathe through the planet's watery lungs. No volcano, no mineral, no geological process we know of can create dimethyl sulfide in such abundance. It is as if biology carries a signature so recognizable that even across interstellar darkness it hums with familiarity. Stephen Hawking once reflected that life is the simplest form of complexity the universe has learned to make, and dimethyl sulfide is one of the quiet proofs of that complexity. The numbers themselves tell a story almost poetic in their precision. A 99.7% probability that the signal is real. Not noise. Not contamination. Not a fleeting illusion woven into data. In the language of science, 99.7% is the threshold where doubt surrenders its grip, where skepticism softens enough to let wonder in, where we begin to whisper the possibility that life has taken root in a world far from our own. Extraordinary claims require extraordinary evidence, Sagan reminded us. And perhaps this is the first piece of evidence extraordinary enough to satisfy even the most cautious mind. But how, one might ask, can light from a world so distant carry the secrets of life across the emptiness between stars? The answer is both simple and sublime. For light is the oldest storyteller of the cosmos. It travels with the patience of eternity, carrying in its wavering frequencies the fingerprints of every gas it passes through. When K218b crosses the face of its star, a few fragile photons slip through its atmosphere, stained with the shapes of molecules, etched with information no thicker than a whisper. By the time these photons reach instruments like the James Webb Space Telescope, they deliver a story older than any human tradition. A story of atmospheric chemistry, of temperature, of potential life. In this way, light becomes the bridge between worlds, a messenger that refuses to die even after 120 years of flight. And so we arrive at the heart of the matter. Why this moment may alter the trajectory of human history. If we confirm life on K218b, even microbial life, it means the universe is not silent, not barren, not empty of companions. It means biology is not a rare accident but a natural unfolding, a cosmic instinct, a tendency built into the architecture of creation itself. It would imply that our galaxy is likely filled with living worlds breathing in rhythms we have not yet learned to hear. That our cosmic solitude has been an illusion born of limited vision. For Peggy Whitson, whose career has always danced between risk and revelation, this discovery feels like the next step in humanity's slow awakening. A moment where science touches spirituality, where data brushes against poetry. When she speaks of K218b, she speaks with the steadiness of someone who has looked down on Earth from orbit and felt its fragility, its loneliness, its hunger for connection. From my own perspective, this discovery teaches us something more intimate than planetary chemistry. It teaches humility. It invites us to see that life is not a crown worn only by Earth, but a thread woven throughout the universe. A thread we are only beginning to notice. It reminds us that curiosity is the heartbeat of our species, and that every answer we find only deepens the mystery we continue to chase. And perhaps the true lesson is this: the universe is not indifferent. It is generous. Generous with beauty, with possibility, with the quiet miracles hidden in its distant corners. K218b may be the first world to reveal itself, but surely it will not be the last. If this journey into the unknown stirs something gentle within you, if it fills you with the soft ache of curiosity, I invite you to let this channel grow with your presence. Like and subscribe so that our footsteps through the stars may continue together, so that this fragile thread of wonder remains unbroken. And as we drift into the next chapter of our voyage, let us ask with quiet anticipation, what other secrets wait in the light of distant worlds? In the quiet drift of the cosmos, where starlight settles on the mind like warm dust, the story of K218b unfolds with a softness that almost belies its power. It rests in the constellation Leo, a silent ember among the celestial lions, waiting for the patient eyes of our instruments to reveal a secret that feels older than memory. 120 light-years separate us from this distant world, a span of time so immense that the light we study left its atmosphere before any of us drew our first breath. Yet across that dizzying gulf, James Webb has whispered something extraordinary to us, a hint of life itself. As Carl Sagan once said, somewhere, something incredible is waiting to be known. And on K218b, that waiting feels almost palpable. The reason astronomers call K218b a super-Earth is not only because it is larger and more massive than our own world, but because it holds within its structure the tantalizing suggestion of a more forgiving cradle for life. It carries nearly 9 times Earth's mass, a gravity that would press into your bones with triple the familiar weight. And yet, somehow, this immense pull becomes an ally rather than an enemy. Its strength binds a vast atmosphere in place, embracing it as gently as the ocean holds a drifting leaf, creating stability across millions of years. Neil deGrasse Tyson once remarked that the universe is under no obligation to make sense to you. And perhaps that is why the harmony of such a heavy planet, nurturing such delicate possibilities, feels like a cosmic paradox worth savoring. In contemplating this world, I find myself learning once more that life flourishes not in perfection but in balance, in the strange, in the unexpected. And K218b embodies that lesson with serene clarity. The hydrogen-rich atmosphere that envelopes the planet is like a thick, shimmering shawl, an ocean of invisible particles that drift and dance above its surface. Hydrogen, the smallest of atoms, becomes here a vast canvas on which temperature, chemistry, and life might paint their masterpieces. On Earth, hydrogen is fleeting, barely a whisper in our skies. Yet on K218b, it is the overwhelmingly dominant breath of the world. This changes everything, from pressure to heat, from the ways molecules combine, to the landscapes we imagine beneath those alien clouds. Life, as far as we can tell, requires water, energy, and chemistry, said Sara Seager, one of the leading voices in exoplanetary science. And hydrogen becomes the unseen conductor of all three on this distant sphere. The hydrogen greenhouse effect on K218b feels like a slow, meditative breath, a warmth that radiates not as a blaze but as a gentle, all-encompassing embrace. Unlike the violence of Venus, where greenhouse forces rage like a furnace, hydrogen spreads heat with remarkable efficiency, smoothing out the extremes of day and night. With tidal locking holding one face always toward its star, you might expect a world divided into fire and ice, a hemisphere seared by continuous daylight, the other frozen in endless darkness. But the hydrogen winds move like slow cosmic tides, carrying warmth across the world, until even the night side glows with the soft heat of possibility. The planet does not merely hold warmth, it shares it, redistributing energy like a living thing, regulating its own temperature. And this alone speaks volumes. And then, there is the number that has captured our collective imagination: the 99.7% chance of life. It floats between us like a fragile miracle, delicate enough to inspire awe, yet strong enough to challenge everything we thought we knew. The dimethyl sulfide detected in its atmosphere, a signature produced only by living organisms on our world, becomes a quiet voice carried across 120 years of darkness. A voice saying, "I am here." This is the moment when science feels indistinguishable from poetry, when data becomes heartbeat, reminding us of the profound interconnectedness of all things. As James Lovelock wrote, "Life and the earth, life and the cosmos are not separate." And in K218b's whisper we hear the echo of that truth, The temperature of 120 degrees Fahrenheit on this world is neither too scorching nor too tame, but a warm, lingering threshold where complex chemistry thrives. It is the heat of a human fever, the warmth of a summer afternoon, the intimate balancing point between comfort and transformation. At such temperatures, water remains tenderly liquid, not boiling away nor freezing into silence. And in that liquid realm, life may find a home more stable than Earth ever offered. I imagine oceans stretching for hundreds of miles, their surfaces trembling under alien skies, each wave a cradle for molecules just beginning to dream of becoming more. These thoughts humble me, reminding me that our own existence is but a single melody in a far larger cosmic song. As I drift through the observations, I find myself drawn not only to the science, but to the feeling behind it. The soft, almost sacred realization that across unimaginable distances, something stirs, breathes, and changes the atmosphere of its home just as we do ours. It teaches me patience, for life does not rush. It unfolds. It teaches me humility, for we are not the center but merely a chapter in a vast cosmic narrative. And it teaches me wonder, the simple, profound kind that keeps us looking up even on the darkest nights. I think of Peggy Whitson gazing at these signals, knowing that what she held in her data was not just science but a message from a distant shore. The universe, in all its silence, had spoken, and her discovery became a bridge between worlds. In her footsteps, #0, 5#, we learn again to listen. And so, as the glow of K218b lingers in our imagination, I return to a question that feels as soft and vast as the night sky itself. If a world so far away can whisper life across the stars, what other voices are waiting for us to hear them? Where the universe breathes in long, slow waves, and every photon seems to carry the memory of distant oceans, the question of life beyond Earth finds its most intimate answer in chemistry. Even the smallest molecule can become a lighthouse in the dark, a whisper crossing light years to tell us that somewhere, something is alive. And among all these whispers, dimethyl sulfide is the one that shines the brightest. Scientists often say that nature writes truth in patterns, and dimethyl sulfide is one of those rare patterns that biology alone seems able to draw. On Earth, it is woven into the breath of phytoplankton, the soft green lungs of the oceans, and nowhere in the geological world has it ever been seen to arise without the aid of life. That is why Dr. Panner, Sarah Seeger once remarked, "If you find a molecule with no known abiotic pathway, you are looking directly at the shadow of life." When this shadow appeared in the air of planet K218b, it was not merely a signal. It was a confession from another world. The chemistry of K218b becomes even more poetic when methane, carbon dioxide, and water join the same breath. These three together form a trinity that rarely coexists in high quantities unless something is constantly renewing them, pulling them out of equilibrium. On Earth, the same pattern rises from wetlands, forests, oceans, from tiny bacteria and great ecosystems alike. Carl Sagan once said, "Life is persistent. Life is stubborn. life reshapes the world around it. And indeed, this trio of gases is the mark of a world being reshaped every moment. Its atmosphere stirred by invisible communities that breathe and metabolize and live. To see methane beside abundant CO2 and abundant H2O is to witness what biologists call a planetary metabolism, a sign that something beneath those clouds is working ceaselessly against the silent laws of chemistry. And then, curiously, beautifully, painfully suggestive, ammonia is absent. On a lifeless, hydrogen-rich world, ammonia should be everywhere, filling the air like a cold chemical fog. Yet K218b is missing it, almost as if something is eating it, removing it, consuming it as food. Harvard astrophysicist Avi Loeb once said, "When the universe refuses to behave like physics, predict, biology may be responsible." The absence of ammonia is such a refusal, a gentle rebellion of nature, one that life alone can sustain. All these clues flow into a single idea, perhaps the most beautiful idea in astrobiology, that a living world is a world out of balance. We call this state chemical disequilibrium. On a dead planet, chemistry drifts toward stillness. Gases settle. Reactions slow. Everything falls into predictable harmony. But on a living world, chemistry becomes restless, forever pulled out of equilibrium by the breath of organisms, by cycles of growth, decay, renewal. James Lovelock, father of Earth system science, once said, "Life is the only force in the universe that reliably pushes against entropy." And that is what K218b seems to be doing. Gently pushing, quietly resisting, maintaining a chemical tension that should not exist unless a biosphere is stirring below the clouds. To discover these truths across 120 light-years is an act of patience and precision, like deciphering poetry etched into the wings of a moth miles away. Astronomers read atmospheres the way monks once read sacred manuscripts, tracing the spectral lines that reveal which molecules drink the star's light and which let it pass. When a planet crosses its star, a thin halo of starlight filters through its atmosphere, and in that halo the universe leaves fingerprints. Some wavelengths grow dim, others remain bright. And from this dance of shadows, scientists reconstruct the very air of a distant world. That is how dimethyl sulfide was found, how methane announced itself, how CO2 and H2O formed the chorus around them. Through these spectral signatures, we hear the chemical music of distant worlds, faint yet deliberate, and we learn to recognize the rhythm of life itself. There is a moment in this journey where science becomes indistinguishable from wonder, where one realizes that these molecules are not merely data points, but messages, carried across the darkness like bottles cast into a cosmic sea. And when we open them, we find not numbers, not noise, but patterns we know by heart. For we too live in a world where methane, carbon dioxide, water, and the absence of ammonia speak of forests, oceans, and breathing things. As I drift through these thoughts, I feel a quiet lesson unfolding. That life, wherever it appears, leaves behind not a shout, but a gentle imbalance. A soft stirring of chemistry that bends the rules just slightly. And maybe the universe is telling us that life is not an exception but a tendency. Not a miracle but a natural unfolding wherever conditions allow. The evidence rising from K218b, faint yet unmistakable, feels like a reminder that loneliness was never our destiny. A planet shaking under the weight of its own biosphere, air rich with organic whispers, molecules in delicate rebellion against equilibrium, all of it forming a portrait of possibility so clear that even across the void we can feel its warmth. The truth behind planet K218b, life evidence, does not merely satisfy curiosity. It enlarges the human heart. And so as we listen to these distant chemical hymns, drifting through the dark with the slowness of lunar tides, we are invited to pause, breathe, and let the thought settle that somewhere beyond our sky, another sky shelters beings who may be wondering about us in return. Perhaps that is the greatest meaning hidden inside these spectral lines. That connection is woven into the cosmos, and every living world, whether ours or another, longs to be known. And as starlight continues to slip through alien clouds, carrying secrets toward our waiting instruments, I cannot help but feel that the universe has begun to speak a little louder, a little clearer, telling us that life is not a rare bloom but a cosmic rhythm, one we are only just beginning to hear. In the soft hush of a distant world, where the starlight drifts like slow falling ash, the question of gravity becomes more than a scientific detail. It becomes a meditation on what life can endure and what it can become. A planet with 3 times Earth's gravity would press every step more deeply into the soil, sculpting bodies that grow low, dense, anchored. Yet as Carl Sagan once murmured, life is the art of adapting to the possible. And in such a place, the possible simply carries a different weight, quite literally. Some forms of life might find strength in that gravity, for a stronger pull means a stronger hold, and a stronger hold invites the stability in which ecosystems can root and flourish. And as I imagine such creatures rising slowly under that tender pressure, I cannot help but feel that life does not resist heaviness, it learns to breathe beneath it. That same gravity would guard the atmosphere like a loyal sentinel, refusing to let precious gas escape into the void the way Mars once did. The red planet's thin, despairing air reminds us that a world must cling tightly to survive. Gravity provides that embrace. And on this distant world, the embrace is firm, steady, almost parental in its persistence. As astrophysicist Sarah Seeger has noted, a planet's atmosphere is its heartbeat. And here that heartbeat is protected and sustained, not dwindling but deepening across ages longer than human memory. The thought comforts me in a way I cannot fully explain, as though the universe itself is telling us that fragility is not a curse, but a condition that can be met with strength. When we drift deeper into imagination, we find ourselves standing on the shores of a hydrogen ocean, a sea deeper than anything on Earth, reaching down hundreds of miles into the dark, where pressure folds water into states unknown to our chemistry books. Hydrogen mingles with water the way breath mingles with longing, creating a liquid both familiar and alien, an ocean where life might sway in slow, luminous shapes. Scientists have whispered for years that water is not the only cradle life can rock in. And here it rocks in a cradle of possibilities we barely have words for. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." And yet in moments like this, I feel it does make sense. Only in a language we have not yet learned to speak. In such an ocean, beneath such a sky, could life breathe hydrogen or inhale methane the way we draw oxygen into our lungs? The idea sounds strange to us, but only because our experience is small compared to the universe's dreams. On Earth, deep beneath the crust, bacteria feast on hydrogen, while others in methane lakes consume and exhale in patterns that mimic our own metabolic dance. "Life will find a way," was a line spoken in fiction, but it has become a quiet scientific truth, a mantra woven into the cosmos itself. If hydrogen is abundant, then life may sip it like morning air, slow and steady, shaping itself around the chemistry of its home. And if methane wraps the atmosphere in its shimmering veil, then perhaps methane breathers drift in that sea, rising like lanterns in the dim blue light. Above them, in cloud decks shaped by alien winds, something exquisite unfolds diamond rain. Carbon squeezed by unimaginable pressure crystallizes mid-fall, transforming each droplet into a flicker of light. A gem born not for wealth, but for wonder. Imagine the world beneath such a rain, each drop singing against the surface. Each impact a reminder that beauty in the cosmos often forms under the weight of extremes. Planetary scientist Tristan Guillot once noted that the giant planets are jewel factories. And here the truth deepens. For even a super Earth can craft its own slow storm of brilliance. As I contemplate these visions, I sense a thread connecting them all. A single lesson woven through gravity, atmosphere, ocean, breath, and rain. Life thrives when conditions challenge it just enough to shape it, not enough to break it. This distant world is a reminder that what seems impossible from afar may simply be unfamiliar up close. That harshness can cradle gentleness, and that even a storm of diamonds begins with a single atom learning to endure pressure. I find myself humbled by these thoughts, drifting through them as if floating in the planet's humid twilight, listening to the slow hiss of hydrogen tides, imagining creatures curled beneath the weight of 3 Earth gravities yet moving with a grace born from necessity. It teaches me that resilience is not loud, that adaptation is not sudden, that life grows strongest in the places where it is asked to bend. And perhaps, as we look outward into these alien worlds, we are also looking inward, into the quiet chambers of our own endurance. Maybe the heaviness we carry in our own lives is its own form of gravity, shaping us, grounding us, preparing us to hold on to what matters. Maybe the storms we survive are our diamond rains, leaving something shining where pressure once lived. In the end, these distant planets do more than expand our science. They expand our imagination, our humility, and our sense of belonging to something vast and tender. As the astronomer Jill Tarter beautifully said, "We are all part of a cosmic ecosystem." And in that realization lies both wonder and peace. a kind of cosmic exhale that lets us rest inside the universe rather than simply observe it. So let the gravity weigh upon us gently. Let the hydrogen seas whisper. Let the methane winds hum. Let the diamonds fall like soft fire. And let us remember that somewhere out there, life may be breathing in a rhythm unlike ours, yet still familiar, still sacred. In the soft, drifting silence of the cosmos, where stars breathe like ancient storytellers, the red dwarfs linger with a patience that humbles even the oldest myths. These small, dim stars burn with a quiet endurance, living not for billions but for trillions of years, far outlasting our sun's brief and brilliant life. Astronomer Jocelyn Bell Burnell once said, "In the universe, longevity belongs to the faint." And her words echo perfectly through these crimson lights that glow like embers refusing to fade. Because they burn so slowly, red dwarfs offer something exceedingly rare in the universe: time. Time for chemistry to breathe. Time for oceans to rise and fall. Time for life to attempt its countless experiments across the quiet ages. The sun gives us a few billion heartbeats for evolution, but a red dwarf grants life a canvas large enough to paint entire epochs of possibility. As Carl Sagan once reflected, "If you want to make life, you must give it time." And red dwarfs seem to have understood this truth long before we did. Yet their gentleness hides a paradox that the cosmos loves to whisper into curious minds. Planets circling these stars often fall into tidal locking, one side scorched by eternal day, the other swallowed by unending night. At first glance, such a world seems hostile, a cosmic coin with one face burning and the other freezing. But the universe often reveals that extremes can hold unexpected harmony. The deep oceans, the thick atmospheres, the ceaseless winds that move like giant celestial lungs, all work together to carry warmth into the dark. Like a heartbeat traveling through the veins of a sleeping world. I often think of these winds as a kind of planetary compassion, an unbroken effort to share warmth with the side that will never see a sunrise. And in that quiet act, there is a lesson for us too. Even in a universe of such stark contrasts, balance is still possible. Scientists have long wondered how the night side of a tidally locked world remains warm enough to cradle liquid oceans. The answer lies in the atmospheric dance that unfolds above it, a thick envelope of gases absorbing the star's delicate heat, redistributing it across the globe, letting the eternal night breathe warmth even without a dawn. Astrophysicist Sarah Seeger once mused, "Heat is a traveler in the cosmos, and it rarely stays where it begins." And nowhere is that more true than on these strange twilight worlds where day and night meet in an endless embrace. Still, the red dwarfs carry a wilder side. They flare. They hiss. They throw tantrums of ultraviolet fire that could strip the skin of a fragile world. Some planets lose their atmospheres quickly, bared to the cold, left to drift lifelessly through eternity. Yet others, cloaked in thick layers of hydrogen or water vapor, withstand these stellar storms with surprising grace. Their atmospheres absorb the violence, soften it, turn it into a muted glow rather than a killing blow. In moments like these, I am reminded of David Grinspoon's words, "Life does not fear this universe. It negotiates with it." And perhaps that is the quiet truth beating beneath all this cosmic poetry. Life does not merely endure, it adapts. It flows. It finds its footing even in the strangest shadows of the galaxy. When we look at these red dwarfs, we are not just seeing old stars. We are seeing tutors in longevity, in patience, in what it means to thrive, not through strength, but through constancy. As I drift through these thoughts, I realize that the universe keeps teaching the same lesson in different languages. That endurance is not loud. That progress is not hurried. That even worlds locked in perpetual night can carry warmth if they learn how to share it. We, too, live under a star that will one day fade. But somewhere in the crimson glow of distant red dwarfs, life may be just beginning its first gentle breath. And so the question that lingers, like a soft echo, is not whether these stars can host life, but whether life under them has already risen, flourished, dreamed. The cosmos is patient, and it is wide. And if red dwarfs are its slow-burning lanterns, then perhaps the night is not as empty as it seems. In the soft hush of the universe, where starlight drifts like ancient dust floating through a cathedral of darkness, the question of how a telescope can smell the breath of a distant world becomes less a puzzle and more a quiet miracle of human persistence. Peggy Whitson once said that space teaches you patience because everything happens on a timescale larger than your own. And perhaps that truth echoes here too. When the James Webb Space Telescope listens to starlight passing through an alien atmosphere, it is doing something like what poets do with silence, tracing meaning in the faintest of patterns. Molecules absorb light in specific wavelengths, leaving behind hollows in the spectrum like fingerprints pressed into glass. And so Webb reads them, molecule by molecule, signature by signature. Astronomer Sarah Seeger once whispered that we are entering an age where planets speak to us through their atmospheres, and Webb is simply learning how to listen. To listen well, the telescope must first tame the star itself, for a planet is nothing compared to the roaring brilliance of its sun. And so the coronagraph steps in like a monk cupping his hand over a candle flame to see the world around it, blocking out the blaze with masks more precise than anything human hands have shaped before. The coronagraph is not just a tool, it is a gesture, a quieting of cosmic noise, a way of asking the universe to whisper rather than shout. NASA pioneer Carl Hennes once said that the tragedy of astronomy is that everything is too bright or too faint at the wrong moment. But Webb has found a way to bend that tragedy into triumph. Because of this gentle silencing, Peggy Whitson can gaze upon worlds smaller and dimmer than Jupiter by a factor of 10, tiny sparks hidden in a sea of fire. It is a feat that once belonged strictly to imagination. Yet here, it is unfolding in infrared pixels across the cold canvas of deep space. Whitson often speaks about the way spaceflight teaches the body to trust the mind. And perhaps her eyes trust Webb in the same way, believing that even the faintest glow can be a planet waiting to be known. But the story does not end at simple sight. For after capturing the light, Webb hands the universe over to artificial intelligence that studies patterns like monks studying sacred scripture. Here, data becomes meditation. Numbers blur into shapes, and algorithms sift through millions of spectral threads to find the one that carries the breath of a foreign world. Stephen Hawking once said that intelligence is the ability to adapt to change. And in these silent calculations, we see that adaptation unfold in real time. Spectral data is messy, filled with artifacts, noise, distortions. Yet AI learns to peel them away until only truth remains. The truth of methane, the truth of water vapor, the truth of dimethyl sulfide. Truths too delicate for raw human eyes, but perfect for a partnership between mind and machine. And so comes the question whispered across 120 light-years of emptiness. How can Webb measure a temperature of 120 degrees Fahrenheit from so far away? Temperature, in the language of the cosmos, is simply the way molecules dance. Faster when warm, slower when cold. That dance alters the light leaving the planet, stretching some wavelengths, compressing others. A thermal rhythm recorded in the laced spectrum like the pulse of a distant heart. As Nobel laureate Subramanian Chandrasekhar once remarked, the universe is not built on force alone, but on harmony. And Webb measures that harmony with the sensitivity of a musician tuning a single string in a vast cosmic orchestra. When you follow the thread of all these marvels, you begin to see that telescopes are not machines built solely of metal and mirrors. They are instruments of longing. They exist because humanity cannot bear the weight of not knowing whether we are alone. Because we have always been creatures who strain our ears toward the night hoping something will sing back. As Webb unravels the atmospheres of worlds like K218b, we learn something subtle but profound. That knowledge is not cold. It is warm, like breath on glass, like fire in darkness. Peggy Whitson herself often speaks softly about perspective, the way looking down at Earth teaches you humility, gratitude, and a strange, quiet kind of love for the fragile sphere that holds us. In this unfolding chapter of planetary discovery, her voice becomes a reminder that science is not just analysis. It is devotion, a long, slow reaching toward wisdom. The deeper lesson tucked inside this cosmic story is that clarity requires stillness. Just as Webb must quiet the light of a star to hear the whisper of a planet, we too learn that understanding grows when we soften our gaze, when we listen with patience, when we allow the unknown to teach us. In the same way that AI sifts through chaos to find meaning, we sift through our own uncertainties, finding direction not in certainty, but in curiosity. Perhaps that is why this journey feels less like a scientific mission and more like meditation, drifting slowly through the dark with a warm voice guiding us from one glimmer of truth to the next. For in the quiet heart of the universe, science becomes poetry. The cosmos becomes a teacher, and each discovery becomes a gentle reminder that existence is far vaster and far more tender than we imagine. And maybe the real revelation is not just how Webb can smell molecules, block starlight, or measure distant warmth, but how these abilities teach us to see ourselves anew. We learn that even the faintest signals matter, that truth often lies hidden behind brilliance. That understanding requires both courage and quiet. The cosmos asks us to be patient, to breathe deeper, to listen more closely. As the last strands of starlight settle into silence, we are left with a simple truth. The universe is not waiting for us to be ready. It is simply offering itself piece by piece, molecule by molecule, in the hope that we will learn how to listen. And if we listen well enough, perhaps we will understand why Peggy Whitson leaned into the darkness with such quiet confidence. Perhaps we will see that the cosmos has always been alive with stories, and we are only now learning how to hear them. In the drifting hush of the cosmos, where dust dances like forgotten snowflakes and young stars glow with the warmth of newborn fire, astronomers turned their gaze toward the CE Antlia system and found a silence more revealing than any sound. A gap, a delicate empty lane carved through the debris disk, a whisper of gravitational presence, a footprint left by a hidden world. As Carl Sagan once murmured, "We are made of star stuff, but perhaps more profoundly, planets too are sculpted from the faintest motions of that same celestial dust." A gap in a debris disk is never just an absence. It is an artist's stroke across a cosmic canvas, a sign that something unseen is sweeping the space clean. When the James Webb Space Telescope caught sight of that gap, astronomers understood it the way a seasoned tracker reads bent grass on a quiet forest trail, the way ripples on a lake reveal the wind that touched it moments before. A forming planet circles its star like a gentle sculptor, gathering dust, swallowing rock, clearing a ring that only gravity could carve. It reminded me of a line from Sara Seager, one of the pioneers in exoplanet science, who once said, "The universe is not silent about its planets. You only need to learn its language." And here, in CE Antlia, that language spoke clearly through emptiness. Within the glow of this system emerged a young world, faint yet steady, carrying the warmth of a surface near 120 degrees Fahrenheit, a cradle temperature where chemistry awakens with gentle urgency. This world was extraordinary not simply because it existed, but because Webb's instruments managed to see it directly, something long thought impossible for a planet with such low mass. It is the lightest planet ever imaged, a cosmic feather in the grand menagerie of massive giants. Its subtle glow is a promise of what our technology can now touch, a reminder that the universe often hides its greatest wonders in soft whispers rather than thunderous displays. Astronomer Michael McIlwain once noted, "Every new detection is not just a discovery. It is a doorway." And indeed, this planet is a doorway into the childhood of solar systems, a moment where dust and ice and ancient elements gather like children building a world from sand. The three rings surrounding CE Antlia reveal a kind of cosmic choreography, each ring marking a different stage of planetary gestation. The inner ring, warm and turbulent, is where tiny grains collide, stick together, and slowly dream of becoming rock. The middle ring, home to the newly found planet, shows the conflict and harmony of birth, where collisions give way to clearing, and chaos organizes itself into orbit. The outer ring, cold and pristine, stores the untouched materials from which future worlds may rise. What touched me most was how all three rings together resembled the rings of a tree trunk, each layer marking a chapter of life, each pattern a quiet testament to time. In CE, Antlia, the star is the beating heart, the rings are the memories, and the young planet is the first conscious dream taking form. I found myself breathing slower as I read the data, imagining the entire system not as machinery, but as a living being, growing, shifting, learning how to become a home. The formation of a planetary system is not the violent chaos many imagine, but a long and patient meditation, a steady conversation between gravity and dust, light and shadow. NASA's Jane Rigby often says, "The universe rewards patience." And in CE Antlia, patience is stretched across millions of years, where each grain of dust carries the weight of future continents, each ice fragment the promise of future oceans. The planet's gravity shapes the rings guide the planet, and the star warms them all in a gentle embrace that feels almost parental. Watching this process from such a distance reminds me that creation everywhere follows a rhythm, a slow pulse that mirrors the rise and fall of our own breath. The system grows, not with haste, but with purpose. Dust spirals inward like pilgrims, offering themselves to become the bones of a world. Ice drifts outward, preserving ancient chemistry like memory sealed under frost. And the planet newly imaged lives in the middle, balancing warmth and silence, gravity and freedom. When I reflect on this discovery, I cannot help but feel humbled, for it teaches a quiet lesson wrapped in stardust. That creation, whether of worlds or of dreams, is often invisible until suddenly it is undeniable. A gap in the dust, a whisper in the data, a glow barely distinguishable from noise. And yet, from such soft signals emerges the truth that another world is coming into being. Neil deGrasse Tyson once remarked, "We are the universe becoming conscious of itself." And standing before the breathtaking evidence from CE Antlia, I felt that more deeply than ever. For here, in this distant nursery of worlds, we are not merely observers. We are witnesses to the universe, learning once more how to build a home. As the story of CE Antlia unfolded, I sensed an unspoken truth woven through the rings. That creation is a partnership. That gravity alone cannot build a world. Nor can dust alone aspire to become one. Only through interaction, through pull and resistance, through clearing and gathering, does a planet emerge. Maybe, in this quiet cosmic process, there is a reflection of how our own lives shape themselves. We clear paths. We gather what matters. We orbit the things we love. And from that slow dance, something new is born. The CE Antlia system shows us that planetary formation is not a moment, but a journey. Not an explosion, but a meditation. It is a reminder that even in apparent emptiness, a gap in a dusty ring, life and structure and meaning are quietly taking shape. As I drift with you through this cosmic scene, I hope you feel the same blend of awe and serenity, the same gentle wonder that comes from watching a world being born. For, somewhere in that distant disk, illuminated by a star too young to remember its own origin, a planet is growing, clearing its path, carving its place, just as we do in our own human way. And I find myself asking, softly, almost like a prayer carried on starlight, if this young world could speak, what story would it tell us as it forms its first breath? In the quiet shimmer of the night sky, when the universe stretches out like a soft breath of eternity, a question rises gently yet overwhelmingly into the mind of anyone who dares to look up. Are we still alone in this boundless ocean of stars? Or has the universe been whispering to us all along? Astronomer Carl Sagan once said that the universe is a pretty big place. If it's just us, it seems like an awful waste of space. And those words drift back like stardust every time new biosignatures flicker through the instruments of our greatest telescopes. As more observatories confirm the faint, living breaths of other worlds, something deep within human consciousness begins to shift, like tectonic plates of understanding, rearranging themselves beneath an ancient ocean. When multiple telescopes point toward the same planet and read the same chemical imbalance, the same improbable mix of methane and dimethyl sulfide, the same pulse of atmospheric disequilibrium that only life can maintain, the universe itself feels a little less silent, a little less indifferent. Neil deGrasse Tyson once noted that we are part of this universe. We are in this universe. But perhaps more important than both, the universe is in us. And in that reflection lies the heart of the transformation that awaits us when biosignatures become undeniable. As certainty grows, philosophy will sense the shift first, feeling it like the change in temperature before a distant sunrise. Subtle but undeniable. The oldest human questions will open their eyes again after centuries of sleep. Questions about purpose, meaning, consciousness. The idea that life exists elsewhere does not diminish us. It elevates us. It stretches the boundaries of what it means to be alive. If other worlds breathe, then life is not a cosmic accident but a cosmic tendency. A gentle law written into the fabric of space-time. And in that realization, we rediscover humility. Not the humility of smallness, but the humility of belonging. Religion too will feel the tremor, though not as a collapse, but as a widening of the sacred horizon. Many spiritual traditions have whispered for ages that creation is vast, abundant, overflowing with possibility. If life blooms on distant shores of the cosmos, it may be seen not as a contradiction but as a continuation of those ancient intuitions. The discovery that other beings share this universe with us may remind humanity that connection has always been our deepest instinct, that the divine may be far more infinite and inclusive than we have ever imagined. Science, however, will feel the impact most directly. When new telescopes confirm biosignatures from multiple directions, the entire foundation of biology and cosmology transforms, not through destruction, but expansion. We will no longer ask whether life can exist elsewhere. We will ask how different, how creative, how wildly diverse the universe can be in crafting living worlds. The discovery will become a mirror, reflecting our own fragility, our ingenuity, our longing to understand ourselves among the stars. And woven through all of this is a gentle responsibility, quiet but immense. If the universe is alive in more places than one, then humanity becomes not an isolated wanderer but a custodian, a caretaker of its small luminous corner. Stephen Hawking once warned that we are just an advanced breed of monkeys on a minor planet of a very average star, but we can understand the universe. And with understanding comes duty. Duty to preserve our world. Duty to protect the fragile ecosystems we may one day encounter. Duty to approach the cosmos not with conquest, but with listening. And in that practice of listening, we learn to treat Earth itself with the reverence we would offer to any other living world. The moment when we are no longer alone will not arrive with trumpets or explosions, but with quiet certainty, a soft confirmation on a scientist's screen, a breath of molecules dancing in the atmosphere of another sunlit world. It will be simple, almost tender, a pattern of light that should not be there, yet is. A whisper across the void, saying, gently, yes. In that moment, humanity will feel something ancient awaken within its collective chest. A widening, a remembering, a sense that the universe was never silent at all. And perhaps the greatest lesson hidden beneath all these revelations is that loneliness was never a cosmic truth, but a human feeling, born from the limits of our tools, our reach, our imagination. As biosignatures multiply, as light itself delivers proof of neighbors across the dark sea, we rediscover something essential. That life seeks life, that consciousness recognizes consciousness. That connection is the quiet gravity pulling all existence into meaning. When the moment arrives, when we can finally whisper that we are not alone, the universe will not have changed. Only we will. Our hearts will tilt slightly toward the stars. Our stories will grow. Our humility will deepen. We will walk through our days with a softer step, knowing that somewhere, under a sky lit by another sun, another form of life may be watching its own horizon, wondering about us. And in that shared wondering, across a distance so vast, it becomes poetic. Two worlds will quietly meet for the first time. In the soft hush of the cosmic dark, where starlight drifts like the breath of ancient oceans, humanity prepares to open a new chapter in its long conversation with the universe. The Biosignature Survey, whispered about in scientific halls and spoken aloud in dreams of explorers, is our boldest attempt yet to listen for the pulse of life beyond Earth. It is a decade-long commitment to observe the atmospheres of nearby worlds with a calm attention almost monastic, to search not for certainty, but for patterns that resemble the faint rhythms of living chemistry. As Carl Sagan once said, somewhere, something incredible is waiting to be known. And this survey is the vessel through which we sail toward that unknown shore. Scientists estimate that in the next 10 years we will scan more than 200 star systems within the quiet cradle of 100 light-years, an act that feels like sweeping a lantern across the walls of a great cosmic cave. Each system becomes a small poem of light, each planet a syllable, each atmospheric signature a possible breath of another world. These worlds will not all be Earth-like, nor should they be. Life is not obliged to echo our familiar shapes, and so astronomers prepare themselves to meet life not as we expect, but as it truly may be. It is here that the idea of agnostic biosignatures rises like a new star on the scientific horizon, a way of searching for life without assuming what life must look like. Instead of oxygen, chlorophyll, or methane in Earth-like combinations, we seek chemical disequilibria wherever they appear. The quiet defiance of molecules refusing to settle into balance. The same kind of defiance that Earth's living breath maintains every day. There is a kind of humility in this approach, a recognition that life may weave its patterns from threads we have never seen. Astrophysicist Sara Seager once said, "The universe is clever, and it will surprise us." And in those words lies a compass guiding us toward gentler expectations, reminding us that the unfamiliar is not to be feared but welcomed. As I let these thoughts drift like slow clouds across my mind, I cannot help but feel that the true lesson here is one of patience. The patience to sit with mystery. The patience to listen for voices that may not sound like our own. Yet the search extends beyond biology, reaching into realms shaped by intelligence itself. Technosignatures emerge as a shimmering horizon of possibility, the faintest hints of artificial gases, the glow of night-side illumination on a distant world, the steady heartbeat of structured radio emissions that refuse to be random. The universe holds its silence with dignity. But even silence can be broken by intention. Freeman Dyson once wrote, "Technology is a gift of God, after the gift of life," suggesting that wherever life grows curious, it may eventually try to reshape its surroundings. And it is this reshaping we might someday detect across the dark velvet between stars. As the biosignature survey unfolds, future observatories prepare to take their places like patient guardians of cosmic truth. The extremely large telescope in Chile will open its 100-foot eye to the night, gathering starlight with a tenderness that feels almost human. From its mountaintop home, it will read atmospheric fingerprints with a clarity no ground-based instrument has ever approached, revealing not only molecules, but perhaps the seasonal breathing of entire worlds. Meanwhile, the Habitable Worlds Observatory, a dream still being carved from the imaginations of engineers, promises to see Earth-sized planets directly, searching for the delicate hues of oceans, skies, and continents bathed in borrowed starlight. It will carry coronagraphs more precise than any built before, capable of turning down the glare of a star by a factor of 10 billion, allowing the faint whisper of a living world to speak for itself. When astronomers speak of these instruments, they do so with voices softened by reverence. For they are not merely machines. They are the extensions of our longing, our curiosity, our desire to know whether life everywhere shares the same quiet hunger to understand its own origins. Neil deGrasse Tyson once said, "We are part of this universe. We are in this universe." But perhaps more important than both of those facts is that the universe is in us. And it strikes me that this search for life elsewhere is in truth a search for ourselves. As I drift with these thoughts, I feel the gentle truth that every observation we make is a kind of mirror. Every world we study reflects back a possibility of what we might become. A planet rich in hydrogen and methane reminds us that life adapts with grace. A planet glowing at night hints at societies who have survived long enough to shape their night skies. And a world full of chemical balance with no signs of life reminds us of the fragility of our own home. In time, the survey will accumulate patterns, hints, statistical fingerprints that whisper of biology, geology, or perhaps something entirely new. Some detections will be ambiguous. Some will fade under deeper scrutiny. But a few may endure, glowing steadily like a lantern against the dark. And when one of those lights is unmistakably biological, when disequilibrium dances so boldly that no natural process can explain it, humanity will face a moment of stillness unlike any before. We will sit with the realization that somewhere, under another sky, chemistry has learned to dream. As I reflect on this possibility, I find myself returning to the quiet lesson at the heart of these searches. The universe does not rush, and neither should we. Every world we study, every molecule we measure, every faint artificial whisper we hope to hear, reminds us that discovery is not merely about answers, but about becoming patient enough to understand them. And so, as the Biosignature Survey begins its slow, meditative sweep of the stars, we listen not with urgency, but with wonder. We listen because the universe has waited 14 billion years to speak, and we have only just learned how to hear. In that listening, in that stillness, we may discover that life is not rare, that intelligence is not lonely, and that across the endless black, there are others who have looked up at their night skies and asked the same ancient questions. And if we are quiet enough, gentle enough, patient enough, we may hear them answering. In the quiet drift of the universe, where every star seems to breathe in slow silver rhythms and space folds itself into a cradle of silence, a single question rises like a lantern in the dark. Are they seeing Earth right now? It is a thought that moves softly through the mind, lingering the way starlight lingers on the edge of dawn. Because somewhere across the cosmic sea, a civilization could be lifting its instruments toward the sky, capturing photons that left our world when our great-grandparents were children. Carl Sagan once whispered that we are a way for the cosmos to know itself. And in that idea lies the quiet astonishment that maybe, somewhere out there, another mind is doing the same. Their telescopes watching our oceans shimmer in blue, our auroras dancing like living rivers, our radio pulse tapping out a human heartbeat across the dark. Our signals have been traveling for more than a century, slipping away from Earth at the speed of light, a bubble of invisible echoes now more than 100 light-years wide. Every message, every broadcast, every accidental whisper we have flung into space is wandering farther than any spacecraft ever could. It is humbling to imagine these signals brushing past distant suns, drifting through clouds of dust that were ancient before Earth was born, reaching star systems we have yet to name. Neil deGrasse Tyson once said, "We are part of this universe. We are in this universe." But perhaps more important than both is that the universe is in us. And perhaps this is why our radio waves feel like a kind of cosmic exhalation, a sign that Earth is not silent but alive. Yet while our signals travel outward, the discoveries coming inward are even more extraordinary. Everywhere we look, every region we study, we find planets, thousands of them, arranged in star systems like beads on a string. And among them, dozens now show the chemical fingerprints of water, carbon, methane, and in some astonishing cases, molecules that on Earth are whispered only by life itself. It makes one wonder if the galaxy is not a barren desert, but a forest of worlds, each holding its own hidden gardens. Frank Drake often reminded us that wherever conditions are right, life seems to appear. And as these new discoveries gather like constellations in our understanding, that sentence feels less like a hope and more like a quiet truth rising from the data. And so another question drifts into view. Gentle as moonlight on water, what happens when we have a list of hundreds of living worlds? The answer feels like the soft turning of a great cosmic wheel. Because with each world we identify, the story of life grows less fragile and less rare. It becomes something woven into the fabric of existence, something that blooms wherever chemistry and time are granted enough room to breathe. These planets would no longer be distant mysteries, but mirrors reflecting possibilities of our own beginnings and perhaps our own futures. Their atmospheres would reveal whether biology is gentle or fierce, whether evolution tends towards simplicity or extravagance, whether intelligence is common or precious. As these thoughts unfold, they lead naturally to a deeper idea that moves like a slow tide beneath everything we know. What if life is not an exception, but a natural expression of the universe? When we examine the building blocks of biology, we find them scattered everywhere. In meteorites, in comet tails, in the cold between stars. Amino acids, sugars, complex organic molecules flourish in places where no sunlight ever falls, as though chemistry itself is reaching toward life, the way a seedling reaches toward light even before knowing what light is. Stephen Hawking once reflected that life could spread from star to star in the natural course of evolution. And perhaps this is the quiet truth we are beginning to witness. Not a universe, indifferent and empty, but one humming with the low, patient music of creation. The more we observe, the more the cosmos behaves not like a desert, but like a field sown with infinite seeds. Most will sleep forever, but some find warmth, water, shelter, and the chance to awaken. It becomes almost poetic to consider that life on Earth might be just one verse in a long celestial song, a melody woven slowly across epochs, whispered by stars, carried by dust, written in the language of atoms and oceans and time. And as new planets reveal their hidden breaths to us, the pattern becomes clearer, the rhythm more certain. Life does not appear to be a rare accident, but a gentle tendency, a cosmic habit, the universe's way of knowing itself through countless forms. And yet, as I let these ideas settle like stardust in the mind, I am reminded of the lesson hidden beneath all of this. The act of searching connects us. It lifts our gaze above the noise of daily life. It reminds us that we are small but meaningful, temporary yet luminous. Each signal we send, each planet we study, Each question we ask becomes a bridge across the dark, a bridge that says we wish to understand and to be understood. When I imagine another civilization receiving the faint heartbeat of our radio waves, I feel a strange tenderness, as if two distant travelers were lighting lanterns in the night to show that neither walks alone. Perhaps this is the real gift hidden inside these discoveries, that in searching for life elsewhere, we rediscover the preciousness of life here. So if they are looking at Earth right now, they might see a small blue world wrapped in clouds, bright with oceans, restless with storms, yet carrying a species that dreams beyond its own horizon. They might see our lights flicker across the night side, our signals spreading outward like ripples on a cosmic lake. And perhaps, just perhaps, they wonder about us the way we wonder about them. And through all of this, another question rises like a soft beckoning in the dark. If the universe is alive with worlds, with chemistry, with possibility, then what else waits for us out there? Listening, watching, dreaming in its own quiet sky. As we drift toward the end of this cosmic meditation, I want to thank you for sharing these quiet moments beneath the distant shimmer of the stars. Tonight's journey has carried us through questions that have no walls, only horizons. Questions about other eyes that may be watching Earth from across the dark, about our radio heartbeat wandering farther than any of us will ever travel, about a universe that may be blooming with life the way spring blooms across a forgotten valley. Each idea we explored was like a lantern held up to the night, revealing that life may not be a miracle clinging to a single world, but a cosmic habit rising wherever chemistry is given the chance to breathe. From the thought of distant civilizations seeing our pale blue world, to the possibility that we may one day hold a list of hundreds of living planets, these wanderings remind us how deeply connected we are to the universe that shaped us. As Carl Sagan said, "We are made of star stuff." And perhaps that is why these questions feel like memories rather than mysteries. If anything from tonight stays with you, let it be the gentle truth that searching the cosmos is also a way of searching ourselves, of remembering that life is precious because it is rare in time, even if it is common in space. And as we wait for the next discovery, the next whisper from a faraway world, we carry with us the understanding that curiosity is not just a trait, it is a responsibility. Thank you for listening with such openness and wonder, for letting your imagination drift across starfields with me, and for being part of a community that still dares to look up. If this journey stirred something in you, feel free to share your thoughts, your dreams, your questions in the comments below. Every word you leave is another small light in this vast night sky. Until our next voyage through the dark and beautiful unknown, may your nights be peaceful, your dreams expansive, and your heart always tuned to the quiet music of the universe.